We want to simplify the following fractions. A fraction is simplified if the only common factor between the numerator and denominator is 1. And two common methods for simplifying fractions are the prime factorization method and the dividing out common factors method. And we'll show both. So looking at our first fraction, 24 divided by 42, using the prime factorization method, we'll determine the prime factorization of 24 as well as for 42. So 24 is equal to, let's say, 2 times 12, where 2 is prime. 12 is equal to 3 times 4, 3 is prime, and 4 is equal to 2 times 2. And for 42, let's start with 7 times 6, 7 is prime, and 6 is equal to 2 times 3, both prime. So now that we have the prime factorization of both, we'll write the fraction as the prime factorization of 24 over the prime factorization of 42. So we'd have 2 times 2 times 2 times 3. And it is helpful to write the prime factors in order from least to greatest. And for 42, we'd have 2 times 3 times 7. And now we simplify. Remember, a fraction bar means division. So 2 divided by 2 is equal to 1, and 3 divided by 3 is equal to 1. The remaining factors represent the simplified fraction, which notice here we'd have 2 times 2 or 4 over 7. So 4/7 is the simplified fraction. Now looking at the same fraction using the dividing out common factors method, we would start with the given fraction. And by analyzing the numerator and denominator, we might recognize that we have a common factor of at least 2. So we could divide the numerator and denominator by 2. Of course, looking above, we know the greatest common factor of 6, but if we didn't have this information, we may start by dividing out 2. Notice how this would give us 12 over 21, and now from here, we might recognize there's still a common factor of 3, so we divide the numerator and denominator by 3. So here we have the same result of 4/7. If we could recognize that 6 is the greatest common factor of 24 and 42, we could have divided by 6 and got the simplified fraction in one step. So the nice thing about the prime factorization method is we actually see the common factors, but if you're good at identifying the greatest common factor between two numbers, the dividing out method can be faster. Next we have 125 over 170, or divided by 170. So using the prime factorization method, we want to find the prime factorization of 125 as well as 170. For 125, we'd have 5 times 25. 5 is prime, and 25 is equal to 5 times 5, both prime. For 170, let's start with 10 times 17. 17 is prime, and 10 is equal to 2 times 5, both prime. So we'll write out the prime factorizations. So for 125, we have 5 times 5 times 5. 170, we have 2 times 5 times 17. Notice here the only common factor between the numerator and denominator other than 1 is 5. 5 divided by 5 simplifies to 1. So the simplified fraction would be 25/34. Or using the dividing out method, we have 125 over 170. This one's probably much faster using the dividing out method. Notice how this number ends in a 5, this number ends in a 0. So both would be divisible by 5, and therefore they have a common factor of 5. So in one step, notice how we do get the simplified fraction of 25/34. So of course you wouldn't be showing both methods each time. You want to find the method that works best for you and stick with it. Now looking at our last two examples, notice how we have mixed numbers. But to simplify them, we're just concerned about simplifying the fraction part of the mixed number. So for 7 and 7/14, using the prime factorization method, notice how 7 is already prime. So we leave 7 as 7. 14 is equal to 2 times 7. Notice how there's a common factor of 7 between the numerator and denominator. 7 divided by 7 is equal to 1. So be careful here. We have 7 as the whole number, and the fraction is 1/2, 1 over 2. These factors are not disappearing, they're simplifying to ones. And of course, using the dividing out method, we would divide the numerator and denominator by 7 and get the same result. 7 divided by 7 is 1. 14 divided by 7 is 2. So this simplifies to 7 and 1/2. In our last example, we have 4 and 8/20. So the prime factorization of 8 would be 2 times 2 times 2. 20 is equal to 4 times 5. 4 is equal to 2 times 2. So we have 2 times 2 times 5. Now simplifying, 2 divided by 2 is equal to 1 here as well as here. So we're left with 4 and 2/5. Using the dividing out method, if we recognize the greatest common factor between 8 and 20 is 4, we can simply divide the numerator and denominator by 4, which would give us 4 and 2/5 as expected. I hope you found this helpful.